So let's do a little mathematics. Why would we want to do math? Because math is awesome, right? So we're going to look at subtraction when you have to borrow. So I'll give you an example. 903 minus 726. So here we are. We say, oh, 3 minus 6. Well, we have 3 of something, and we have to give away 6 of something, but we can't give 6 away from 3. That wouldn't leave us with anything that made any sense right now, right? So no, we look over here and we say, there's nothing in the tens column either. Here we are. I mean, remember, in the ones place, you have a dot, right? And if you add up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them, there's the ones place. Hello, ones. There's the ones place. When you add those up, then they all become, boop, let's fix this. There's the ones place. They all go on and say, one of them is 10. So we consolidated them. Look, we put them all together, and they all get represented by a dot on the 10 side. But then if we wanted to, we could instead take that little dot, and we could unpack it again. Say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which really means we borrowed something from the 10 and unpacked it back into the ones. Why? Well, because it's easy to subtract from here, right? So what if we did this? What if we instead had, how about this? This is fancy stuff. What if we had 1, 2, 3 things in the 10 spot, and 1, 2, 3, 4 things, and we wanted to subtract? That's 3 and 4, which is 34. We wanted to subtract, let's say, 17. Could we pretend that these are dots? Sure we could. But let's just remember here, this is going to be 34. 3 tens and 4 ones. And we look and we're like, well, here's 7 ones here. We want to subtract. Can't do it. There's not enough. 1, 2, 3, 4. 7 doesn't fit into 4. So what do we do? Well, we're going to go ahead and borrow one of the 10s. Bloop. That becomes a 2. And what do we do with the 10s? We stack them up here. 1, 2, 3, 4. Oh, that's not very good. Let's do that again. We stack them up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? All right, so what did we do? Well, we just made this 14. Look at that. I'll even make it the same color. All right, so this is 14. So 7 from 14 is, well, let's see. Let's cross them out as we go. 1, 2, 3, 4, 5, 6, 7. What's left? 1, 2, 3, 4, 5, 6, 7. There's 7 left there. Now we come over and there's just 2 dots. There's just 2 here. That's 20, right? So if we had a 2 here, 2 minus 1, which is really 20 minus 10, 2 minus 1 leaves us with 17. Okay. So this was the 10's place. This is the 1's place. All right. So we were really doing 34 minus 17. Okay. And so again, what did we do? Well, instead of making dots, we imagine, we're going to borrow from the 3. Borrow what? Just borrow 1. Downgrade it to a 2. What happened to the 1? It went to making this 4 a 14. 410, 14. 14 minus 7 is 7. 2 minus 1 is 1. See? It all checks out, whichever way you think of it. All right, so let's go back to our problem then. Here we had 903 minus 726. Boy, what a hard one to start with. So we can't borrow from the 0, so that really kind of stinks, right? So what do we have to do? We have to borrow from the 9. Okay. We borrow from the 9, and this makes this an 8, makes this a 10. Well, that's great. We still can't subtract 6 from 3, so now we got to borrow from the 10. That becomes a 9. And this becomes a 13. So now we end up with 13 minus 6. Well, I know 12 minus 6 is 6, so this must be 7. I'll let you think that one through. 9 minus 2 is also 7. How interesting is that? And then we just have the 8 downgraded to 8 minus 7 is 1. Now, the cool thing about math is if you really wanted to, you could always go back and add these together and see if you did it right. If you're at all uncertain, you just add them back together. I know that 6 and 6 is 12, so 6 and 7 must be 13. I know that 7 and 2 is 9. That makes 10. Carry my 1. And I have 7, 8, and 9 right here. And it checks out because it was the same as what I subtracted from. So with mathematics, you can always go in reverse to check and see if you made an error somewhere along the way. So it's easiest when you're going from subtraction and then back to check with addition. And checking your math is a very important step a lot of times. Let's see, what else do we have? How about another example? 534 minus 287. All right, I'm getting a little wonky here, aren't I? I'm going a little sideways. So, here's what I'm going to do. 7 from 4. 4 is not big enough to give everything we need to lend out 7, right? So we have to borrow from this one. Well, it's not a 0 this time. I can go ahead and borrow from this and make this a 2. That's no problem. I don't have to think about this yet. So I borrowed from it, and then my 4 becomes a 14. Wow, that 14 minus 7 pops up every now and then, doesn't it? Well, 7 and 7 is 14, so that's what must be what's left. Now I'm looking over here, and I'm trying to subtract 8 from 2. I can't do that. Can I borrow from my neighbor? Absolutely. Let me just downgrade this 5 and make it a 4. And don't forget, there we go. I made that to a 12. What did I do? Well, remember how you used to carry the ones, carry the extra digit over when you're adding things? Well, when you're subtracting, the opposite of carrying is borrowing. So we take the 12, which we had to borrow the 1 from over here, and it really is 10 hundreds if you're interested. 12 minus 8, it's 8, 9, 10, 11, 12, must be 4. And then what are we left with? 4 minus 2, that's an easy one. 247. Could I go back and add these two smaller numbers to check? Absolutely, it should add up to 534. How about another example? Now remember, you can always pause this video and check again afterwards. But here, let's try it. Let's try 413 minus 276. And you don't have to write sideways like me. 6 can't be taken out of 3. And so we need to borrow. Well, hey, here's a 1 here that we can borrow. Boop. That becomes a 0 for now. And where did the 1 go? Well, it went to making this a 13. If you want to write it up here, just cross out the 3 and write it as a 13, that's fine. Well, I know that 6 from 12 is 6, so 6 from 13 must be 7. Oh, look, now I have a 0 here. I can't take 7 from 0. What do? Well, I borrow 1 from its neighbor, make this a 3, make this a 10. 10 minus 7, I can do that. That's 3. And then 2 from 3, that's a 1. All right, and I could always add these together to double check. So the big idea is that these are special problems that you probably would run into a lot. Could you use a calculator? Absolutely, but you're trying to build up your brain in order to think about using these numbers, because someday, and someday soon, you're going to be using more and more complex numbers. Sometimes they're going to have parts of numbers in them. Sometimes you're going to have numbers that you've never even heard of. Sometimes they're going to have numbers that you don't really know what the numbers are. We just talk about them in terms of letters and things that are just completely unknown to us. So you start out with numbers that we're really comfortable with, and you get your brain programmed to use those numbers, and then pretty soon your brain knows how to handle the more complex stuff. So trust me, this is worth it. Now here's what I'm going to have you do. I'm going to have you work through a couple problems. How about we do 533 minus 286? How about we do 851 minus 673? And then how about you do 734 minus 568? Now again, these are all special example problems where you have to borrow in order to solve the problem. You don't always have to borrow when you subtract. Sometimes, like this, 864 minus 241. You can just do a normal subtraction. You say 4 minus 1 is 3, 6 minus 4 is 2, 8 minus 2 is 6. You didn't have to do any borrowing there. Look, there's nothing going on here. But a lot of times you're going to have to borrow. And just remember that borrowing is just the opposite of carrying the one or other digit that you're using. So here are your three problems. Problem 1, problem 2, problem 3. I want you to pause the video, and then when you've tried them, then you need to unpause the video, and I will explain what the answers are. And then you check. All right, go ahead and pause now. All right, so hopefully you got somewhere with these problems, and I know you're just learning these now, but you know what? You can do it. And we're going to look at these and give you the solutions. So 6 can't be taken from 3. 3 is just too small. Not enough dots in 3. Remember the dots? Not enough dots in 3. So we're going to borrow from its neighbor, make this a 2. Make this 13, right? We borrowed the 1 from the 3 and put it here because that 1 really represents 10 dots. So you might like to rewrite it on top. I like to just put a 1 out front. So 13 from 6, well, I know 6 and 6 is 12, which means 6 and 7 must be 13. Oh, I want to take 8 from 2. That's not good. Again, borrowing. Oop. Oh, look, I made a mistake. That happens sometimes. That's why I have an eraser. Look. That becomes a 4. This becomes a 12 because I borrowed a 1 and put it there. We have 4. 8 from 12 is 4. 4 minus 2 is 2. How about this one? Well, 3 can't be taken from 1, but I can borrow from the neighbor, make this a 4. This becomes an 11. I know 3 and 7 is 10, so that must make this 3 and 8 is 11. And then I can't take 7 out of 4. 7 dots from 4 dots? That doesn't make sense. I'm short 3 dots. But I can borrow from the neighbor, make this a 14. 7 and 7 are doubles. It makes 14. I remember that from flashcards. And then here we go. 7 minus 6. That's an easy one. Don't even bother. All right? So same thing here. One of these special problems that we make you borrow. Borrow from what? Well, hey, conveniently, this 2 pops out, right? There's a 3 downgraded to a 2 by what? By 1. This becomes a 14. Let's see. 8, 9, 10, 11, 12, 13, 14. Oh, look, that's 6. 8 and 6 is 14. I remember that. And then I have to borrow from the 7 because 2 is not big enough to handle 6. And that becomes a 12. Well, 6 and 6 are doubles. That makes 12. And 6 minus 5 is 1. All right, now there's lots of other example problems out there that you can do. Make sure that you have any of your questions answered. And then why don't you try a few on your own. Have fun.